the centroid of the given composite area with respect to point O. So what is the composite area is this way. So I have a straight line, a rectangular portion, and here I have a circle of radius equal to this. So this is a circular area. So if I connect this, comes here as tangent, right? And here at the center there is a triangle that is removed, cut portion. So the radius of this is 25. The radius of this is 25 centimeter, and here I have a triangle. This is a right angle triangle. The dimension of this triangle, the right angle isosceles triangle, 15 centimeter and 15 centimeter. Right, that is cut and removed. And the center location O from here is at a distance 75 centimeter. And this height is 25 centimeter. This height is, so I should just redraw this picture. This is of 25 centimeter. So that has to be at the height of radius, right? So this, and from here I have the circle, right? So if I extend this, is going to be a circle like this, but it is not this. This is all a composite area, and this triangle is cut out, removed. So if that is so, now you should find out centroid of this. So this side is 25 centimeter. So this side is 25 centimeter, and this length till the center is 75 centimeter. At the end, you see that it is of circular area. So this is just had come till this point. So it is 3/4 of the circular circumference is visible, and 1/4 of the circle area is merged with this rectangular area, and there is a triangular portion removed. So now this is all referred by x and y axis, holding this as origin. So now find out the composite area, centroid of this composite area. First find out the composite area and find the centroid of this composite area. So how do you go about doing this problem? So for that, first you should discretize this entire area conveniently. So first one is just refer this as complete rectangle as 1, and then look at there is a circle, that is 2. But there is a portion of common area of circle and rectangle, that is this quarter circle. So I should remove that, because then only it would become one composite area. So take circle and add this portion is difficult. Rather, I will add this area and the entire circle area, subtract this quarter circular area, so that I would get this, and then remove this triangular area, so that I would get my composite area. So how do I get my composite area? Is this way. So 1 is rectangle, 2 is circle, 3 is quarter circle, 4th one is triangle. So this is 4th one. So area 1, A1 plus, so total area, how do you get? A1 plus A2 minus A3 minus A4. So this would give me the total area. So what are those area describing? A1 is a rectangle area, A2 is the circle area, A3 is this quarter circular area, A4 is the triangular area which is cut and removed. So that I get my total composite area of this given figure. So if that is so, I can find out what is my centroid now, right? So it is recommended that you follow the table procedure so that you would not make any mistake. Even you make mistake in one calculation, one part calculation, the other part calculation give you partial marks. So let us just do the sum having one table form so that it is easy always, right? So let us have the table. So the first column of the table always serial number. And then second column is geometry. Third column is area, what is there? And fourth column is xi. Why I put x subscript I have now 4 areas described. So individual area centroid is what is x1, x2, x3, x4. So I have this. And similarly I'll have yi. After having this xi, yi for the individual areas, I can find out its first moment, that is a into xi, right? A into xi. So here it is, if I say this is a I individual, then it is a into xi is what is first moment about y axis. I'll get this value, right? Then I would get similarly ai into yi, which is my first moment about x axis. So once I have this, then I would be able to have, so I have my first moment and area, so I would be able to get my x bar and y bar, right? So this is the required table. So in this, let us now fill our data. So what are the data? First one is A1 area. So A1 area defined how? It is a rectangular area. And this rectangular area is defined with respect to x and y axis with respect to point O. I have my centroidal axis here. So the dimension of this as per this diagram is 75 by 25, right? So take the calculator and then start calculating. So what is the area of this rectangle? 75 into 25, 75 into 25, that is 1875, 1875 centimeter square, right? That's the area. And what is my xi? By symmetry itself, we can say 75 by 2, that's equal to 37.5. 37.5. What is my yi? By symmetry, you could see 25 by 2, it is 12.5. So now what is ai xi? It is this a1 into x1. So that is 1875 into 37.5. So this is my first moment of area. Value is 70312.5. Unit of this is centimeter power 3. And 1875 into 25 is what is 46875 centimeter cube. These distances are in centimeters. So this is all the unit for these columns. So now first one is found. So what is my second area? Second geometry is the circle geometry. So where is it located? My reference is here. This is my xy. So the circle is somewhere here. This is the circle. So this is the center, right? So this is the location. So now here I have my centroidal location for the circle given by this. So this is YC, XC of the circle. And dimension here, from here where this is located by x2 distance, and this is located by y2 distance. So I can just calculate now the required area. So what is area? The radius of that is 25. So this radius given here, the radius of this given is 25. Right? So I can find out it is pi into 25 square. So that is 1963. Right? 1963.5. And what is x1? X1 is 75. It is located, see this point is located from point O at a distance 75. And what is y1? Y2 in this case is located at a distance 25. So now first moment is 1963.5 into 75. That is 147,262.16, right? And 1963.5 into excuse me, sorry, 63.5 into 25 gives me 49087.5. Right, so this area is added. So these two areas are added. I have got now this, but there is a common area of this quarter circle that I should subtract. So third is minus A3. So that would be with respect to same reference, X and Y axis. Where is it located? This is the center of this area. This area is A3. So now it is to be subtracted, so it is minus area. So that would be 1/3 of that circle area. So 1963.5 divided by 1/4 of that divided by 4. So it is 490.88. 490 minus 490.88. And then the centroid of this, see, very, very important. So here is what the students do make mistake. You have to be very careful. So I have my centroid here, centroidal axis here. You know these distances from this point is what is 4r by 3 pi. This distance is what is 4r by 3 pi that we have seen. But now you have to write here x3 and y3 from this point O. Where is it located? So how do you get that? How do you get that? So I will write it here with the red color only so that you'll understand it's very important. So let us have that obtained 75 minus 4 into 25 is the radius by 3/5. So this is that answer. This is 25, right? Do you follow me at this point? So let me just enlarge this. So this is 75 by 3 pi because 75 is still here. So this distance is 75 from here. Right? So this distance from here is what is 75. This is 75 and this distance is what is 4r by 3 pi. So I have to locate the centroid of this. So this distance is what I needed. So this distance is given by 75 minus 4 into r25 by 3 pi. So the value of that is value of that is 4 into 2500 divided by 3 divided by pi is 10.61. So 75.
Excuse me, sir.
Yeah.
Sir, had we just taken 4 into 25 by 3 pi, what would we have got?
4r by 3 pi.
Yeah, if we had just taken that value instead of subtracting it from 75.
So that's different because see, I want to locate for this composite area with respect to point O. Look at the question here. That's what I always see the students do make a mistake. Question, read it. Locate the centroid of the given composite area with respect to the given origin O. So from here, where is it located for an entire composite area? So you know individually the formula. That is what we were doing it in the first slide. So here, for example, we look at here for a quarter circle. From the center of the circle, it is 4r by 3 pi and 4r by 3 pi. But this placement in a composite area, where is it located? That's very important. So this quarter circle location is now here. That is why I draw this geometry with respect to xy. So it is located here. So the centroid of that I know from the standard formula from the center of the quarter circle at a distance 4r by 3 pi and 4r by 3 pi. So this I have to locate with respect to O. That is what is my x3 and y3. And x3, y3 positive value because the entire geometry is in first quadrant. But area is negative because that has to be subtracted. Do you get?
Yes, sir. Understood, sir.
So this is now going to be 64.39. So 64.4 let us take. Right. So this is now x3. And what is my y3? Can you say, Pranesh?
So that will also be sir 4 into 25 by 3 pi.
Look at it again. So from the center it is 4r by 3 pi, this distance. But I needed with respect to O. So I have to measure from here what is this distance. So how do I get? Look at this.
So that will be, so that we have been given as 25.
Yeah. Minus.
So 25 minus 4 into 25 by 35.
Good. So is it clear? So
Yes,
this is
sir.
what you have to do. So now you work out this and tell me. So that is 4 into 25, 100 divided by 3 divided by pi, that is 10.61 minus 25. So 14.4. 14.4 is what is y3, right? So after getting these values, now I can find the first moment. So that would be 490.88. Multiply that by 64.4. That gives you the value here, but that's minus value as that is area, subtracted area, 31,612.67. And similarly, 490.88 multiplied by 14.4. Again, that is minus area, minus 7068.67. So this is that. So you have to continue this with one more area geometry. So let's do that. That is the triangle which is removed, right? So again, it is interesting that you have to carefully do that. So now this is fourth area. So fourth area is to be, where is it located with respect to given xy axis set? This is my given xy axis set. So with respect to that, the triangle is located somewhere here. So this is the cutout portion, A4 area, where this point distance from here is 75. Whereas this triangle height is 15, base is 15. And the base is from here at a distance 25. 25, that is also given. So look at here in the composite area, this triangle is located, the base is located from here 25, whereas this point is located 75 from here, and this is the location of my triangle. So now I have to get the moment of that and that area again to be a negative area because it is removed from the given composite, right? So what is that area? Minus half into 15 into 15. So how much it is? 225 by 2, that's equal to minus 112.5. This is area. And what is x4? So x4, how do you get the centroid of this area? So centroid of this area is somewhere here with respect to this point. 1/3 from here, 1/3 from here. So now the centroid of this, where is it from xy axis set, is what is my interest. So what is my x4 is this distance. This is x4. What is my y4 is this distance. So that I have to get. So now x4 will be 75 minus 1/3 of 15, that's 5. So 75 minus 5, that's equal to 70. Whereas y4 is 25 already plus 5. So 25 plus 5, 30. So any doubt in this? Any doubt? If you do not have doubt, I'm happy. So 112.5 into 70, that's going to be minus 7875, and 112.5 into 30, that is 3375, minus 3375. So you did this table requirement. So now what does that you have to do is you have to calculate the total area, the sum of this column 3, this column value, and then sum of first moment about y-axis and x-axis here, right? So this one is sigma ai xi. This is sigma ai yi. So let us calculate that now. So simple addition. So 1875 plus 1963.5 plus minus 490.88 minus 112.5, that's equal to 3235.125. 3235.125, right? Let me check once again. 1875 plus 1963.5 minus 490.88 minus 112.5. So that is 3235.125, right? So 125 or 13. And this sum now is first moment about the y-axis. So that would be 70312.5 plus 14726.16 minus 31612.67 minus 7875. So that is equal to 178092. See, I get here 178087 I get, right? And the third column, last column. So last column would be moment about x-axis. So that would be 46875. Right, 46875. Am I right? So that's 1 minute. 1875 into 12.5. So that is 1 So this value please correct. Check this value. Check that value. That is not this. This is half the value. So this value is not correctly calculated. That is 2347.5. 2347.5 is what I get. And next one is plus 49087.5 minus 7068.67 minus 3375. So that is equal to 6201.33 is what I get. So now it is simple from mathematical definition that x bar into A is what is sigma AI xi, which defines qy, first moment about y-axis. So I can get my x bar as this sigma AI xi by total area. So sigma AI xi in this case is 178087 divided by area 3235.13. So I get my x bar. Similarly, I would get my y bar would be given by first moment about the x-axis, that will be y bar into A, and that would be same as sigma AI yi. So I would get y bar as sigma AI yi by total area. So that's happened to be 62081.33 divided by 3235.13. So I will get my answer. So this divided by 3235.13 gives me 19.2 centimeter. 19.2 centimeter is y bar, and my x bar is 178087 divided by 3235.13. That is equal to 55.05. 55.05 centimeter. So this gives me the location of centroid. So what do you mean by this? How do you locate now? So let us just look at the given geometry and try to put these values. So the given geometry is with respect to this axis set x, y, and it has got left end is rectangular portion, and it comes till the center of the center of the circular portion, and there I have a triangular slot given like this, and you see that you had a circle that comes out here like this, right? So this is given. So this is given section. So in this section, what is removed is only this portion is removed. So this portion is removed. So let me just remove the unwanted lines. So this all. So this is given section. So in this given section, now my centroid is located at a distance 55.5 from here. So this center point is 75 from there, but it is 55.5. So somewhere here I have my YC axis. YC axis, and this distance is x bar, which is 55.05 centimeter, and y bar, so that I would be able to get XC axis. So that is 19.2 centimeters. This side is 25. So somewhere here I have a XC axis. So this height is my y bar, which is 19.2 centimeter. So this intersection is what is centroid. So supposing if this is your plate, a homogeneous plate, if I have pin here where I tie and then I hang it, this section XY plane is perfectly horizontal. That's the meaning. Because this weight is uniformly distributed and you are given this sample composite area and you are asked to do a task that you have to drill a hole and hang that plate so that the plate should be horizontal perfectly, you have said, then you are supposed to first determine this location, what is called the centroid CG location of this. So at this point, if I drill a hole and then hang it entire thing, this entire thing is perfectly going to be horizontal, right? So that's the application of this finding centroid of the composite area. So any doubt, I have taken this problem so slowly I explained you so that you would understand and you will not make any mistakes while calculating, right? So this table is very important. Any doubt? Anybody? Any doubt anyone has got? Please ask me. There's some message. Students have put.